Tesla didn't make the Model 2 cheaper by cutting corners. It made it cheaper by cutting complexity. At first glance, that sounds like marketing spin. But once you understand how traditional cars are built, the logic becomes impossible to ignore. Most compact cars on the road today hide between 300 and 400 interior components behind their dashboards, doors, and seats. Every switch, motor, wire, clip, and decorative panel exists for a reason. But each one is also a future problem waiting to happen. Over time, these small problems don't stay small. They stack up, quietly draining money from owners year after year. Think about how most people experience car ownership. It's rarely the engine that ruins the budget. It's the constant stream of minor failures. A window switch stops responding. Seat motor grinds itself to death. Climate controls flicker. Interior trim cracks or rattles. None of these failures are catastrophic on their own. They're expensive because they involve labor, diagnostics, and parts that were never designed to be replaced easily. Simple window switch can cost $150. A seat motor failure can climb past $400. Over a decade of ownership, these costs snowball into thousands of dollars that buyers never consider at the dealership. The shocking part isn't that these things fail. It's that the industry accepts it as normal. Traditional automakers design interiors around features, aesthetics, and marketing checklists, not long-term reliability. Each new feature adds another motor, another wire, another connector, another software layer. Every connection point is a place where plastic meets metal, where moisture can seep in, where vibration loosens tolerances, where heat slowly degrades. Insulation. Failure isn't a question of if, it's when. Tesla looked at this entire system and did something radical. Instead of asking how to add more features cheaply, it asked what could be removed entirely. The Model 2 isn't about stripping comfort for the sake of cost. It's about eliminating failure points at the source. If a component doesn't directly improve durability, safety, or essential usability, it doesn't belong in the car. Philosophy alone removes hundreds of parts before production even begins. The result is an interior built around molded, multifunctional structures rather than dozens of individual components. Instead of assembling separate panels, mounts, brackets, and fasteners, Tesla uses large molded sections designed to perform multiple roles at once. These panels aren't decorative afterthoughts. They're structural, engineered to resist cracking, warping, and fatigue for 15 years or more. Fewer parts mean fewer seams, fewer fasteners, and fewer opportunities for vibration and wear. This approach completely changes how the car is built. Traditional compact car interiors take around 15 hours to assemble. The time isn't spent because workers are slow. It's spent aligning, fastening, wiring, checking, and rechecking hundreds of individual components. Every step introduces the possibility of human error, a clip slightly out of place, a wire pinched just enough to fail later, panel tightened unevenly, creating future rattles. Tesla cut that process down to roughly 6 hours, not by rushing workers, but by eliminating steps altogether. Entire interior sections arrive prefabricated and slot into place with minimal adjustment. It's closer to modern construction techniques than old-school auto assembly. The fewer decisions a worker has to make on the line, the more consistent the result becomes. The consistency doesn't just reduce defects, it eliminates them. Cutting assembly time by nearly 9 hours saves between $800 and $1,200 per vehicle before it even leaves the factory. That savings doesn't come from cheaper materials or lower wages. It comes from efficiency. And that efficiency is one of the key reasons a $15,000 Tesla is even possible. When people ask how Tesla can sell a car at that price without sacrificing durability, this is the answer. But cost is only half the story. The real breakthrough is what this means for long-term ownership. Fewer parts mean fewer electrical connections. Fewer connections mean less resistance, less heat buildup, and less corrosion over time. Electrical failures are among the most common and frustrating issues in modern cars, especially as vehicles Age. By reducing wiring complexity, Tesla reduces the chance of mysterious faults that are expensive to diagnose and repair. Even sound insulation follows this same philosophy. Instead of layering traditional insulation materials that degrade, absorb moisture, and add weight, Tesla relies on structural rigidity to reduce noise at the source. A stiffer structure vibrates less. Less vibration means less noise. A solution that doesn't rely on materials that will sag, peel, or crumble over time. Again, fewer materials, fewer problems. This design philosophy also changes how the car ages. Traditional interiors are full of parts that wear unevenly. Buttons fade, motors weaken, panels loosen. The car doesn't suddenly fail. It slowly feels cheaper and more broken with every passing year. The Model 2 avoids that decline by removing the very components that cause it. If there's no motor, it can't fail. If there's no switch, it can't wear out. If there's no seam, it can't rattle. Critics often mistake simplicity for cheapness, but they aren't the same thing. Cheap design cuts material quality while keeping complexity. Tesla did the opposite, kept durability and removed complexity. That's why the Model 2 isn't just cheaper to buy, it's cheaper to own. Fewer repairs mean fewer service appointments. Less downtime and less uncertainty. Owners aren't constantly waiting for the next small failure to appear. This simplified design also makes servicing easier when something does go wrong. A car with fewer parts is easier to diagnose. There are fewer things to check, fewer systems interacting unpredictably. That reduces labor time and lowers repair costs even further. For owners, that means less time sitting in service centers and more time actually using the car. Production scaling benefits just as much. Fewer parts mean fewer suppliers. Fewer suppliers mean fewer delays, fewer logistics issues, and fewer quality variations. Inventory management becomes simpler. Build quality becomes more consistent across every unit. Problems like misaligned panels and inconsistent interiors, which plague traditional manufacturers at scale, become far less common when there are fewer variables involved. This consistency matters because it builds trust. Buyers don't want to gamble on whether they'll get a good unit or a bad one. A simplified production process reduces that risk. Every Model 2 is built the same way, with the same components. Following the same steps, that uniformity is what allows Tesla to scale production without sacrificing reliability. The most important insight behind the Model 2 is that affordability isn't about making things flimsier. It's about making them smarter. The automotive industry spent decades convincing buyers that more features meant more value, even as ownership costs quietly rose. Tesla flipped that equation. Value isn't measured by how many buttons a car has. It's measured by how little it costs to own, maintain, and live with over time. A car engineered with fewer parts doesn't just save money up front. It saves money every year after. It reduces stress, inconvenience, and uncertainty. It turns car ownership back into what it was always supposed to be: predictable, reliable transportation. That's why the Model 2 isn't just another cheap car. It's a rethinking of what a car actually needs to be. So when people ask whether a car with fewer parts can really outlast everything else, the answer isn't theoretical. History already tells us that simpler machines last longer. Complexity ages poorly. Simplicity endures. Tesla didn't remove 300 parts to shock people. It removed them to eliminate 300 ways the car could fail. In doing so, it may have quietly built the most durable, affordable vehicle of the modern era.